Types of flow. First one is steady flow and unsteady flow. Steady flow means it is defined as the type of flow in which all the fluid characteristics like velocity, pressure, density, etc. Have learned about this properties, that is velocity, pressure, density, etc. at a point do not change with respect to time. Steady flow means the velocity, pressure, and density of a fluid do not change with respect to time. For example, a constant discharge through a pipe. Constant discharge through a pipe can be considered as a steady flow. Next is unsteady flow. So, unsteady flow will be the opposite meaning of steady flow. Unsteady flow means it is defined as a type of flow in which the fluid characteristics like velocity, pressure, density, etc. changes with respect to time. That is what is called as unsteady flow. Second one is uniform flow and non-uniform flow. Uniform flow is defined as a type of flow in which the velocity at a given time, the velocity at a given time does not change with respect to space. The velocity at a given time do not change with respect to space. And non-uniform means the velocity changes with respect to space. Here in the figure you can see uniform flow and non-uniform flow. You can see uniform flow and non-uniform flow. Here you can see that the velocity do not change with respect to space. The velocity do not change with respect to space. But for non-uniform flow, you can see that the velocity changes with respect to space. So we can say the flow through a long straight pipe. Okay, the flow through that the first case A, the flow through a long straight pipe of uniform diameter. The flow through a long straight pipe of uniform diameter has uniform flow, and the flow through a long pipe having varying cross section, that is the cross section is varying, so there is change in velocity with respect to space, and that type of flow can be called as non-uniform flow. It can be easily understood from the figures. And the third one is laminar flow and turbulent flow. Laminar flow, you can see in the figure, this is laminar flow. That is case A is laminar flow. It is defined as a type of flow in which the fluid particles move along well-defined path. That is, you can see they are moving along well-defined path. They are moving along well-defined path or streamlines. They are moving along well-defined path or streamlines. And you can see these lines, these movements of these lines, that is streamlines, are straight and parallel. You can see they are moving along straight lines and they are parallel. That is, you can see one layer moves over the other. That is, one layer moves smoothly over the adjacent layer. You can see this layer is moving very smoothly over another adjacent layer. You can see the first layer moves smoothly over the second layer, and the second layer moves smoothly over the third layer. So you can see it is the fluid particles are moving in well defined path. Then it is called as laminar flow. And this type of flow is also called as streamlined flow or viscous flow. Streamlined flow or viscous flow. Next is turbulent flow. Turbulent flow is that type of flow in which the fluid particles move in a zigzag manner. You can see the fluid particles move in a zigzag manner. You see the difference between laminar and turbulent flow. You can see the particles is moving in a zigzag manner. Hence, the flow is in such a way that the adjacent layers cross each other. The adjacent layers do not move smoothly over another as a laminar flow, but the adjacent layers cross each other and do not have a well defined path. Laminar flow il oru well defined path in the presence undu, but turbulent flow there is no well defined path. That is, one layer is moving over the another. For example, that is the flow of blood in small veins. Flow of blood in small veins is a laminar flow. That is, they are moving in layers. But if you see the flow in a canal or the flow through a river, you can see one layer is crossing the other. Okay, that is called as turbulent flow. So, flow through a river, canal, etc. In the water bodies, you can see it is turbulent flow. But the flow in the small veins, that is flow of blood in the small veins, is a kind of laminar flow. That's the difference between laminar and turbulent flow. That is, in case of laminar flow, they are flowing in layers. They are flowing in well-defined path. But turbulent flow, one layer is crossing over the other. That's the difference between laminar and turbulent flow. Next is compressible and incompressible flow. Compressible flow means it is a type of flow in which the density of the fluid changes from point to point. Compressible means the density of the fluid is changing from point to point. That is, we can say rho is not a constant because the density is changing from time to time, or from point to point, the density is changing. For example, we can say flow of gases. Okay, gases flow through a small openings. The flow of gases through small openings can be considered as compressible flow. That is, gases are considered compressible. Okay. Then incompressible flow. But then what will be incompressible flow? Compressible means the density changes from point to point. So incompressible means the density is constant. For compressible, the density changes from point to point, and for incompressible, the density is constant. And the next one is rotational and irrotational flow. Rotational flow means it is a type of flow in which the fluid particles, that is, while they are flowing along streamlines, rotate about their own axis. While flowing along the streamlines, they rotate about their own axis, then it is called as rotational flow. But if the fluid particle do not rotate about their axis, but if the fluid particle is not rotating about their axis, then it is called as irrotational flow. Then next is 1, 2 and 3-dimensional flow. You can see the difference through an expression, that is 1, 2 and 3-dimensional flows. Here you can say the first expression is regarding one-dimensional flow, second one regarding two-dimensional flow, and the third one is regarding three-dimensional flow. One-dimensional flow means it is a type of flow in which the flow parameter such as velocity is a function of time and one space coordinate only. You can see u is given by f of x, but v is equal to 0 and w is equal to 0. That means it is a function of one space coordinate only. ഒരു സ്പേസ് കോർഡിനേറ്റിന്റെ മാത്രം ഫംഗ്ഷൻ ആയിട്ട് റെപ്രസെന്റ് ചെയ്യാൻ പറ്റുള്ളൂ in case of one-dimensional flow. Then what will be two-dimensional flow? The velocity can be expressed as a function of time and two rectangular space coordinates. That is, it can be represented as the function of two space coordinates. Then what will be three dimension? Three dimension can be, it will be expressed as a function of three mutually perpendicular space coordinate. First one, only one space coordinate. Second one, two space coordinate. And third one, three space coordinate. That is about 1, 2, and 3 dimensional flows. That is about the types of flow. Next is the method of describing fluid motion. The method of describing fluid motion. So for describing fluid motion, we depend on two methods. For describing the fluid motion, we depend on two methods. One is Lagrangian method and the next one is Eulerian method. For describing the fluid motion, we depend on two methods. One is Lagrangian method and the next one is Eulerian method. So first we can talk about the Lagrangian method. Lagrangian method means, in considering the Lagrangian method, a fluid particle is followed. A single fluid particle is followed during its motion. That is, we are focusing only a particle. A single fluid particle is followed during its motion and its velocity, acceleration, density, etc. are studied. That is, we identify or label a particle. We identify or label a particle, and that particular particle is tracked. That is, we are tracking a particle and studying its properties like velocity, acceleration, density, etc. That is, ഒരു fluid particle choose ചെയ്യുന്നു, then we are tracking that particle. First we are identifying a particle. ഒരു particle identify ചെയ്യും, then we are tracking that particle. ഒരു particle identify ചെയ്തു, അത് കഴിഞ്ഞിട്ട് ആ particle track ചെയ്യും, then we are studying its properties like velocity, acceleration, density, etc. We are focusing on a particle. That is, we are identifying a particle and we are tracking or following that particle. ഒരു പാർട്ടിക്കിൾ ഐഡന്റിഫൈ ചെയ്യും, എന്നിട്ട് ആ പാർട്ടിക്കിളിനെ ട്രാക്ക് ചെയ്യും. എന്ന് വെച്ച് കഴിഞ്ഞാൽ അത് മൂവ് ചെയ്യുന്നത് എവിടേക്കാണോ അങ്ങോട്ടൊക്കെ ട്രാക്ക് ചെയ്യും. വി ആർ ഐഡന്റിഫൈങ് എ പാർട്ടിക്കിൾ ആൻഡ് ദെൻ വി ആർ ട്രാക്കിംഗ് ദാറ്റ് പർട്ടിക്കുലർ പാർട്ടിക്കിൾ and we study the properties like velocity, acceleration, density, etc. Then we describe those properties. So a single fluid particle is chosen. That particular particle is followed. That is, we are tracking that particle. A single fluid particle is chosen. We are tracking that particle and we are defining or we are describing its velocity, acceleration, density, etc. That is Lagrangian method. Next is Eulerian method. Eulerian method. In case of Eulerian method, the velocity, acceleration, pressure, density, etc. are described at a point. First case, we are tracking a particle. In the second case, we are focusing on a point. In the first case, you are tracking a particle. എന്ന് വെച്ച് കഴിഞ്ഞാൽ ഒരു പാർട്ടിക്കിൾ ഐഡന്റിഫൈ ചെയ്യുന്നു, ആ പാർട്ടിക്കിളിനെ ട്രാക്ക് ചെയ്യുന്നു, പാർട്ടിക്കിളിന്റെ പ്രോപ്പർട്ടീസ് വെലോസിറ്റി, ആക്സലറേഷൻ, ഡെൻസിറ്റി എക്സെട്ര ഡിസ്ക്രൈബ് ചെയ്യുന്നു. ഇൻ ദ സെക്കൻഡ് വൺ യു ആർ just focusing on a position. You are focusing on a position of the particle. That is, the velocity, acceleration, pressure, density, etc. are described at a point in flow field. That means you are focusing your attention on a particular position. First one, you are giving importance to particle and you are tracking that particle. While second one, you are giving importance to its location or its position. That is, you are focusing a particular position And in that position, particles may come and go. Okay, you are focusing your attention on a particular position, and in that position particles may come and go, but you are only focusing on that particular position. Lagrangian method, you are focusing on a particle. You are focusing on a particle and you are studying the velocity, acceleration, density, etc. of that particle. But Eulerian method, you are focusing on a particular location or on a particular position and then studying the velocity, acceleration, pressure, density, etc. of the fluid present at that position. ഒരു പൊസിഷനെ ഫോക്കസ് ചെയ്തിട്ട് ആ പൊസിഷനിൽ ഏതൊക്കെ പാർട്ടിക്കിൾസ് വരുന്നുണ്ടോ ആ പാർട്ടിക്കിൾസിന്റെ എല്ലാം വെലോസിറ്റി, ആക്സലറേഷൻ, പ്രഷർ, ഡെൻസിറ്റി എക്സെട്ര ആർ ഡിസ്ക്രൈബ്ഡ്. And this is the most common method. Eulerian method is the most common method used. In Eulerian method, you are identifying a particular location, a particular fixed location, and you are following the change in property that occurs within that location. The Lagrangian method, you are focusing on a particular particle, and Eulerian method, you are focusing on particular position or location. That's the difference between Lagrangian method and Eulerian method. Now next is streamline, streak line and path line. Streamline, streak line and path line. So first we can know what is streamline. Streamline means it is a space curve. It is a space curve such that its tangent anywhere, its tangent anywhere gives, it's a space curve such that its tangent anywhere gives the velocity vector at that point. It is a space curve. You can see it is a space curve. And if we are drawing a tangent, we can obtain the velocity vector. That is what is called as streamline. Next is path line. Path line means it is a path which is followed by a fluid particle over a period of time. Path which is followed by the fluid particle over a period of time. A path which is followed by a fluid particle. ഒരു fluid particle തന്നെ follow ചെയ്യുന്ന ഒരു path ആണ് path line. That is, this is the same particle and we are just representing the different positions of that particle. ഒരു പാർട്ടിക്കിളിന്റെ തന്നെ പല പൊസിഷൻ ആണ് ഈ റെപ്രസെന്റ് ചെയ്തിരിക്കുന്നത്. സോ പാത്ത് ലൈൻ മീൻസ് ഇറ്റ് ഇസ് ദി track. It's a track of a particle. That is the path which is followed by a fluid particle over a period of time. That is what is called as path line. Then you can see two path lines. These are two path lines. They can either intersect each other or they can form a loop like this. Okay, two path lines can intersect like this or they can form a loop like this. Next is streak line. Streak line means it is a line which is connecting all the fluid particles. It is a line which is connecting all the fluid particles. That is what is called as a streak line. Then it takes the orientation or it takes the shape while the particle is flowing. Particle അങ്ങോട്ടാണോ flow ചെയ്യുന്നത് ആ ഒരു shape ആയിരിക്കും streak line വരിക. That is a streak line gets the orientation or changes orientation along with the change in direction of the fluid particle. That is, due to change in direction of flow, the orientation of streak line also changes. So a streak line consists of all particles in a flow that has previously passed through a common point. In path line, you are tracking only one particle. That is, it is a line which is joining. A streak line means it's a line which is joining several fluid particles But path line means it is a line or it is a path which is followed by a fluid particle over its period of time. That is, this is a particle, let us assume it as A. And this is the path which is followed by A. This means it is a path which is followed by particle A. A path which is followed by a fluid particle over a period of time. That is called as path line. Then coming to straight line means it is a line which is joining all the fluid particle. A line which is joining all the fluid particle is termed as straight line, or we can tell it as the locus of temporary locations of all particle that have passed through a fixed point in the flow field. So the orientation of the straight line changes as the direction of flow changes. When the direction of flow changes, the orientation of the straight line also changes. That's the difference between path line, straight line, and a streamline. Okay, thank you.